Mhm.
Are we good?
Yeah.
Okay. Have we another question?
Yeah. I looked at number 12, and they have percentages, and they also have the p-value, which is 0.0219. I don't know how to find it in the how to use the empirical rule when it has this kind of problems.
Okay, so in question 12, I'll just read that out, but I'll do it on my white screen this time. So what we have here, a recent study has shown that about 39.9% of American adults fit the medical definition of being obese. A large medical clinic would like to estimate the percentage of their patients who are obese. So they take a random sample of 500 and find 170 are obese. Suppose that in truth, the same percentage holds for the patients of that medical clinic as for the general proportion, which is 39.9%. The standard deviation of this information is 0.0219. So they're mixing percentages and the decimal versions. So if the clinic took repeated random samples of 500 and found the sampling proportion who were obese, in what interval should the proportions fall about 95% of the time? Okay. The empirical rule that they're talking about says that the distribution is normal and that right in the middle is the mean. And if you go 3 standard deviations either side, if you go 1 standard deviation, which is from here to here, in that range, can you remember what percentage of all the people would be? What percentage is within 1 standard deviation of the mean?
68.
That's the 68 one. We don't want to know that one, but that's the one. Now, if you go 2 standard deviations, which is from here to here, can you remember that that one then is what percentage?
95.
That's the one we want. So what we need to do now is find out what these 2 numbers are. And they will be the 2 numbers that go in your answer. The from, and so it's between this guy and that guy, right? So I need to find what the mean is. And I also need to find, oh, and I want my answers rounded off to 2 decimal places. So I'll keep that in mind when I'm doing it. I need to know the mean and I need to know the standard deviation. So we've got lots of percentages out here. Now, the standard deviation of this one was that. Now, if the clinic took repeated samples of 500, okay, so it's 500. And found that the samples who were based into what interval should the sample proportions fall about 95% of the time. So I'm going to use the p-value of 0.399. That's the 39.9% that they mentioned in the question.
Okay.
Whenever you do calculations like this, you always use decimals in the calculations. When you're finished, you might leave them as decimals. You might turn them into percentages. In this particular case, they want you to leave them in decimals, so that is fine. So the mean is going to be that fella. And the standard deviation is going to be that fella, which in your case is 0.399. How do you get Q again?
How do you get? You subtract 0.39 minus 1.
There you go. And then I believe in this case it's 500. Pretend a little Siggy thing's not there. And you can tell me if I hit this right. So I have a square root of 0.399 times 0.601 divided by 500.
I get 0.02189.
Yeah, and they want what, 2 decimal places? So how about 0.02?
Yeah.
Okay. Now, if I take this number and I round it off to 2 decimal places as well, I'll call it 0.4. Now, do you notice that I still use the real numbers to get my answer, but I rounded off after the event? So I didn't use 0.4 here and here. If I did, my answer might be a little bit different because of that. Now, 2 standard deviations. We know this guy is 0.40. And we know a standard deviation is 0.2, so that one would be 0.42, but this one, the one we want, would be 0.44. And then going backwards, 1 standard deviation, going back another one would get me to there. Are you happy with how I found these 2 numbers?
Not quite. Okay, I'm not quite understanding how you get 0.40. And then after that, moving on further.
Right. Okay, let's where that came from. Round off 0.399 to 2 decimal places, and the answer becomes 0.40.
Oh, okay.
You're rounding up, and the 39 gets rounded up to 40.
When do you know when to do that?
Well, the question told me to 2 decimal places, so that's how I knew to do it. If the question had said 3 decimal places, I would have left that alone, and I would have rounded this thing off to 3 decimal places as well. So it was in the question.
Okay.
If you're talking about rounding off, typically 0 to 4 rounds down and 5 to 9 rounds up, except sometimes in this textbook 5 rounds down, so go figure. So we go with that number. Now, if you take the mean, which is 0.40, and you add 2 standard deviations, you get to 0.44. That as a calculation would look something like this. The mean plus 2 lots of the standard deviation, and that would get you 0.44. And then the mean, take away 2 standard deviations, and that would get you the 0.36. So that's what the calculation looked like. And these are the numbers that you start and finish your interval with.